Okay, so data sufficiency. First time we've done quant in a couple of months. It's been a long time. So, but data sufficiency stuff. Problems with upfront. That means work not in the back. Specifically, what that means is work that you can do. It may be actual work involving working the problem. It may just be conceptual preparation, but upfront meaning before you use either of the two numbered statements, like work that you can just do with the prompt. Again, let's show the copyright page. There it is. All these problems are copyright GMAT2. They are from the free GMAT prep software. Remember, when you submit problems, free GMAT prep software only, not the paid GMAT prep pack. Thank you. Okay, let's do a problem. Here you go. Give it a shot. Again, remember where the multiple choice answers are found. There they are. All right, go for it. I should probably be picking an answer to this thing decently soon. Remember, this is a test where you can't not pick an answer, so if you have to guess, then you should guess. Also, in general, I'm most interested in the answers that people pick towards the end here, because those are usually people who are on the cusp of the problem. But I think I have 20 or 30 seconds. Okay, let's take an answer here. If you don't have one already, you should definitely guess. Again, this is not a test that lets you not answer problems. So, and this is where the multiple choice answers are found. Underneath your name, please click once. If you click twice, it will undo what you picked. So, let's go and pick something. Let's see, lots of non-responders here. We have Machine, Cat, Jackie, Joycelyn, Lance. Okay, let's take a look. So the theme is this. Yeah, thank you for, again, you got to take a multiple choice, guys, so this test doesn't let you not do it. The theme is problems with upfront work. So the point is, and I mean, there's no consistently obvious sign when you are dealing with something like this, but basically when you see a prompt that has more stuff in it than normal, you should think about whether you can do something with it. I mean, it's a very primitive sounding piece of advice, but it's pretty consistently good if you think about it. Like, if most of the stuff is in the prompt, then you can probably do stuff with the stuff. And, you know, they're using very big words there. But in general, I mean, again, it's not always true. Nothing is always true on this exam, really. But when prompt contains a lot of stuff, and when it contains most of the stuff in the problem, try to work with it. Or at least see where you can go with it. Like, see, you can even play this free association game and say, where does my mind go when I look at this kind of stuff? So here, you have these two angles. By the way, if it wasn't clear, I think it's probably clear to most of you because a bunch of people picked the right answer here. But the X and the Y refer to these angles. So these are less than 90. Also, when you review the problem, you should think about why the conditions that are there and how the problem will change if you remove them, which we'll get into that. But these lines are parallel. The horizontal lines are. And then you want to know, basically you want to know which of these things is the longer segment. So what can you do with this? What do you think, chat box? How are x and y equal? That's what you mean? That's what you think about? When, under what circumstances they might be equal, sort of thing? Is that what you mean by that? Because the prompt doesn't say that they're equal. Yeah, you want to think about how the angle affects the length. If you were allowed to be over 90 degrees, that would also complicate the problem because as NL points out, this stick would switch, meaning that the angle would start slanting in the other direction. So we're not saying that x and y are equal. In fact, we know that we're not saying that because statement 1 directly contradicts that. So you wouldn't have a self-contradictory problem. But in the picture, it sort of looks like they are. But remember that in data sufficiency, the diagrams are not to scale because they can't be. Oh no, the green is just meant to show that we are talking about angles. Like that, because in the original picture, it might not have been completely clear what x and y are supposed to mean. So, but you can think about this. I mean, it might be tempting. Some people are tempted to start throwing geometry theorems and stuff at it, and that's really what you don't really want to be doing here. Because these problems, the thing that's cool about these problems and that's consistent about them is that you don't have to draw on obscure knowledge of things like geometry. In fact, in geometry in particular, the problems tend to depend on very, very basic knowledge, like the kind of stuff that, like either stuff like the area of a triangle is this, or just stuff that you can figure out by looking at pictures. So as far as how does the angle affect the length, yeah, right? The point is just to investigate. And when it comes to pretty much the data sufficiency section across the board, this one word kind of summarizes the majority of what you need to do to succeed at data sufficiency. You should really just play with stuff and see what happens, right? So here are some lines. Here's a copy of the lines that are up there. Just see what kind of relationship exists. Just throw stuff at it. Throw stuff at the problem. And look for relationships. I did not spell that correctly. And look for relationships. All right, so let's just toss some lines up there and just watch what they do. Point. So here's a line. Here's another one. Here's another one. Here's another one. And I could do cool animations before, but I can't animate stuff on your presentation. Would really be a great idea to start doing that sort of thing. But if you look at the relationship here, what's the relationship? Yeah, if you look at this, and you can estimate the size of these angles if you want to. This is probably about 80 degrees. This is maybe, I don't know, it's probably like 5. This one looks like it's probably right around 40 or so. This looks like it's more like 25. It doesn't really matter exactly how many degrees those are, but as you go in this direction, the angles get smaller. And then you can definitely see that as you go in the same direction, the segment gets longer. And then, yeah, the other realization to make, because the things that are in these problems are always in the problems for a reason. So the other thing to think about is why the 90-degree thing is important here. And if you do draw an angle that makes a 90-degree, if you do draw a segment that makes a 90-degree angle, you'll realize that that's the shortest path between the two lines. It's going to be perpendicular. So there you go. So basically, this is the relationship. This is not a theorem that you really know. At least this is one that I've ever seen as a theorem, but if you investigate, you will readily discover this sort of thing. So we'll talk about what happens if you lift that restriction on the angles here in a moment. Because in general, if you lift restrictions, then things will usually change, because they don't usually give you things that are superfluous or irrelevant. So if they say something like this, then normally it will do something, which conversely means that if it's not there, then the result will be different. So yeah, as the angle gets smaller, the segment gets longer, right? So, and then notice you have a yes-no question. As always, the point with yes-no data sufficiency questions is to see whether you can make both cases happen. So we've used this device in a couple of other study halls on data sufficiency, but translate the yes statement, translate the no statement. The yes is PQ would be shorter than SR. The no statement would be that PQ is not shorter than SR. And then the question is, can you make this happen for each of those two statements? So you make this little device, you can translate it to checking off boxes, so to speak. So, well, we know that x is greater than y. Then we know this. So y is a smaller angle, which means that SR is going to be, it's actually going to look exactly like this. It's going to look like x is somewhere on the left of this picture and y is somewhere on the right of this picture. So in that case, it's guaranteed that PQ is going to be shorter and that SR is going to be longer. So this is going to happen. This is going to be impossible. So statement 1 is sufficient. Smiley face, if that makes sense. Looking, I see that people are adjusting answers to the correct answer as they go. All right, smiley face. Looking in particular for smileys from people who actually didn't have okay, we're on statement 2. So now that you've done this work up front, you also know what matters. Like, what is the only thing that matters really about these angles? What is the only thing about them that will shed any light on this question? Yeah, it's the comparison, right? So once you discover this relationship that we have written down here, you should hang on to that relationship in your mind. And more generally, what this means in terms of this problem is the only thing we really care about, as far as the angles are concerned, with respect to the angles, is which one is bigger. So, and the thing, see, this is, and you can notice patterns like this as you go through the problems. But if you just have the sum of two numbers, we're going to have no idea which one is bigger because they're interchangeable. You can generate specific cases just to drive that point home, right? You could have 30 for x and 60 for y, and you can turn around and have 60 for x and 30 for y. So it's going to be possible to make either one of these guys bigger than the other one. So you could make that one shorter, or you can make the other one shorter. So both of these are a possibility. So it's not sufficient. Overall, it's A alligator. Let's take a look at what happens if we do get rid of the 90-degree relationship. See what happens if we do that. Take us to the page. And when you review, I mean, when you're working the problems under time conditions, of course, this is not the sort of thing you would want to distract yourself with. But you should think about why restrictions are in place when you view the problem. I mean, sometimes they're just like bookkeeping things to prevent numbers from blowing up. Like, if you're dividing by an x, they're probably going to tell you that x is non-zero, just so you don't divide by 0. So some of them are just boring restrictions, like I don't want to divide by 0. But a lot of the time they do interesting things. Right? So when you review the problem, among other things, you should think about what happens if you list restrictions or alter them. If you list or alter, the answer would be an envelope. Yeah, they have these weird emoticons that are enabled by default here. So I guess the E in parentheses or something like that. You list or alter restrictions or conditions. Right, because if the angles don't have to be less than 90 degrees, and we can make the same sort of diagram that we made in the last page, but now we have to include things that slant. So these are the ones we did before. Same pattern obtains if we do that. But we also have to include things that slant in the other direction. Look at that. See, so now the relationship doesn't really work anymore in the same way. Like the angles, as you go in this direction from left to right, the angles get smaller. But see, now the length, it's not consistent anymore, right? And until you reach 90, it's actually getting shorter. And then low 90, shortest length. And then now it's getting longer. So that's going to spoil fun here. So it's true, if x plus y is equal to 180, then they're going to have the same length, and that would make this question sufficient again. So you can play around with a bunch of stuff like that. You can create your own like tweaks to the problem that create different answer choices. That's how you really win the game, is by making that kind of stuff happen. Because then when you mess around with the problems like that, it'll give you some insight into the problem creation process, which once you know what goes into creating the problems, you can also gain some insight into how they might be solved. You know, especially when you look at weirdo problem statements like this. If you make your own problems, you start seeing where they're going with stuff when they create the problem. It's pretty neat. Any questions about this? No, let's do another problem. Let me find a particularly delicious one. Let's see, how about that one? Oh yeah. Go for it. That's where you find multiple, it's so big. Let me shrink that graphic. That's where you find the multiple choice answers underneath your name in the A through E area. Give it a shot. Okay, ladies and gentlemen, definitely time to field a guess here. What makes you feel better about fielding a guess? This is the status of the class answers so far. So we are basically all over town. Not as many people like E, but you're just all over the place on this one. So just guess. Everybody else is doing it. No reason to feel bad about guessing. This is how they roll, right? I mean, nobody's going to have this kind of stuff memorized, because it's not advanced math. It's just, they have a very nice way of picking it at corners of stuff that no one is going to have ever learned as a rule, but that you can discover by just kind of knocking around a little bit, right? Same thing with the last problem that we looked at with this stuff in it. I mean, no one's going to have ever learned this as a theorem in geometry, but you can just like look at some angles and cool, look what happens, right? So same sort of thing here. So this is a thing. And then if you look at the statements here, then there's not going to be like algebraic combinations that you can start messing with. So, and 1 is a very special number. So it's 0, so it's -1. But when you think of this, this should start, I mean, this should speak to you. I mean, this should say to you, I mean, it's not really going to talk, but if it could talk, it would be like, how can this happen? So, what are some ways? What are some ways in which you can raise a thing to another thing and get 1? List some possibilities. Okay, you can raise things to the 0 power. And you know what? See, if that didn't come to mind right away, it should. You know why, right? Like you should all think about the 0 power thing right away. Because why? Look at what's on the board. It's because of the first statement, right? Because like when you, like if you write problems yourself, this is the kind of thing that you are totally going to figure out really quickly. Which is like statement 1 has to be created by whatever human being is creating this problem. Like it doesn't just happen, right? And so you should think about, because like if you were the person writing this problem, you would actually have to think about, I'm going to make this non-zero. Which is not really anything you would think about doing unless something happened when it was 0. Because otherwise this would be really random and you would not think to do it, right? So like think like the test maker is the point here. I mean, they're not going to make up random statements for no reason, right? So if they do this, then n equals 0 must be something special here. Because otherwise, otherwise, why? Just ask yourself, right? Like otherwise, why would they dedicate a statement to ruling it out? I mean, and again, when you start writing some problems, you'll see, right? Because the statements that you create are going to be relevant in some way to the situation. So one of the possibilities, so let's move this over here so that we have room to list possibilities. So z to the n equals 1, and then we're going to say what is z and what is n, right? So, okay, you could have almost anything to the 0. So like z to the 0 equals 1. So that would mean that n is 0. What about z? And what kind of numbers can you? Is there anything that you can't do this with? Not quite anything. Almost anything. Yeah, it can't be 0. So it can be anything except 0. 0 to the 0 is not a thing that is defined. Because if you try to do that, if you try to use laws of exponents, you'll realize that 0 to the 0 would require division by 0. So you can just memorize that 0 divided by 0 is not a thing, but if you play around exponents, you'll figure out why not. So that's one possibility. Okay, and then you can also have 1 to the n equals 1. And here there's absolutely no restriction at all. So z is 1 and n is any number at all. And then lastly, we have this, which again is also a thing that you should be thinking about. Because when you think like the test maker, why would they waste a statement telling me that z is a positive number guy? Because they must be ruling something out. Aha, they are, because you could have a negative value for z. So more think like the test maker again. why would they tell us Z is positive if that wasn't a thing that did something to things? They wouldn't. So yeah, right. Look at that. You can raise -1 to stuff. So -1 to, and what kind of ends will do that? This would be Z is -1. If you realize that it's even, that's going to be enough to solve this problem. Although there actually are other possibilities. Does anybody know what those are? I mean, it could be even integer. It could be plus or minus even integer. Or, yeah, -1 to the -1 is actually -1. Because that would be 1 over -1 to the first. And that would just be -1. It's another odd power. Can't take a square root of it because it's negative, but you're rocking up the right tree. We got those. We got the plus or minus in front of that. We got the negative even. I mean, this is enough to solve this problem, by the way. But just a little bit of extra fun here. What about something like this? What about, 1/2 power is not going to work because that'd be square root of a negative. But what about that? What does that mean? I remember, make sure you know what these things do, right? So the over 3 in the root that becomes the type of root that you're taking. So that is going to be a cube root. Cube root. And that's still -1. But then this is a power. So it's going to be that whole thing in a jiggy raised to the second. So that would also work. I mean, you don't have to do that here, but it's just kind of neat. So it could be plus or minus even integer, or it could actually be plus or minus fraction of even over odd. Because if it's a negative power, all it's going to do is flip it around, which is not going to change the fact that it is negative or +1. So you don't need this to solve the problem, but it's just cool. It's a cool thing that is cool. All right, well, now let's look at this. Let's look at this. So in statement 1, again, this is your classic upfront work type of situation. Because you could kind of figure these out as you go. I mean, as you work with the statements, you could like generate just enough of this to resolve the issue. But then the problem is that you're not doing the assembly line kind of thinking anymore. Like you're bouncing back and forth between thinking about this and thinking about the statements, and there's not as much continuity. This is the advantage of upfront work here, is that you do all of this kind of thinking at once. And then you think about the data sufficiency aspect. I mean, if you're bouncing back and forth between this and those, that's going to make your life much more difficult. And that could be the case here. Because, I mean, I doubt there are people who don't really know that these are things. It's more of an organizational aspect of, let me generate all this stuff up front so that I don't have to keep half thinking about it and half thinking about data sufficiency, right? So statement 1. And let's call these cases, let's call them Roman numeral 1, 2, and 3. Okay. So with statement 1, if n is non-zero, that could be either case 2 or case 3. So z could be either 1 or -1. That's 2 possibilities. So that's not sufficient because there's more than one possibility. Okay. Statement 2. Z is positive means it's not case I, but it could be either of the other ones. So that means that actually Z could be anything except 0. So that's not sufficient. That's infinitely many possibilities. But if it's together, then you know what the score is, right? If it's together, then it's got to be case 2. So z is 1, and this is sufficient. So, you know, a lot of people pick E on this one because you can't find what Z and N are. And that, like, there are people who actually figure out all of this and then blow the problem because they don't realize or they don't remember that the focus is only on Z. So if you need to remind yourself of that, then write it on the paper, maybe even in more than one place. But if that kind of mistake is made, then you should learn from it and not make it again. And if you pick, I think a lot of people like choice A. I think it's because you didn't think about -1. So, in fact, more people picked A than the correct answer. That's a problem. So, if you were in the A picking group, I mean, there's the obvious takeaway point, which is you should not forget that negative numbers are things. But there's also the less obvious and probably much more useful takeaway, which is the whole thing about thinking like the test maker. Because, you know, you don't need to think of negative numbers randomly from scratch here, which is what a lot of people think this means. And not at all. I mean, look at this, right? I mean, they told you Z is positive, which means you should think about the flip side of that in addition to thinking about that. Again, that should be the biggest takeaway from this problem, is if they like put a restriction in one of the statements, they're probably putting that restriction for a reason. So you should think about what it does if the restriction is not there. Any questions about this? Getting a couple people typing in my text box. So you can wait a second. Let's see what they are typing. Couple of people. Now it's just KAR is typing in the text box. People pick E because because even if we have both statements together, the letter A can still have any value at all. Because if we have two statements together, then we know it is Z is 1 and N is whatever the heck N wants to be. And so I think people are mistakenly thinking that you have to determine every letter in the problem, like both Z and N have to have numbers, which is not. All they're asking you for is Z. So there it is. Okay, hopefully that makes sense. All right. I don't think people have text in their boxes anymore. Difficulty levels are irrelevant to your life because they will not help. They will not and cannot help in any way. In fact, the fact that people have to ask this question is ironically proof that difficulty levels are a useless concept. If you have to ask what they are, it means you don't know what they are. And then you know what that means. It means you can't strategize around them. So. Nope, 0 to 0 power is not a thing. I mean, okay, so let's just explain that real quick if you want an explanation of it. Like, the deal is that exponent rules are things, right? Like, why? I mean, a lot of people haven't really thought through, like, why is non-zero number to the 0 equal to 1? I mean, this is not some random convention. I mean, just think about exponent rules. Like if you have some number to the power over some number to the other power, then that's going to be the difference of the powers. So what that means, like if we pick a non-zero number, let's pick 87, the number I wore in high school football. I mean, if you do like 87 to the 5th over 87 to the 5th, then that is 87 to the power of 5 minus 5. Oh, look, that's 87 to 0. But of course, I'm dividing the same number by itself, so that's 1. And this will work for every number except for 0. But if you try to do this with a 0 where the 87 is, then it's going to be a whole world of hurt. You're going to be trying to divide 0 by itself. So, and 0 divided by 0 is not a thing that has a value. Because you learn in calculus that you can make 0 over 0 have any value you want it to, but it's not fine. So this works for every number except 0. All right. That's another problem, yeah. Do it. How about this? Go for it. Okay, time to pick a thing, an answer to this problem. Let's take a look. So, still got 4 or 5 non-responders. Again, there's only so much I can do to force your hand here, but this is a test where you can't not answer the questions. So, I should answer the questions. All right, let's take a look. So this is what I was saying at the beginning of the class about how if the prompt is full of stuff that looks like you can do things with it, then you can probably do things with it. And notice that this is an issue, right? So when you see this, what should at least go through your brain in a sort of brainstorm here is, okay, I need to think about signs. So is VE, is there a variable called E? I'm not sure what that means. I don't see a letter E in this problem. Oh, this is a funky way of writing positive. Okay. Right. So, and remember what this means. Again, here's your device for yes/no questions. Yeah, the yes case here would be, can I make the positive? And the no case would be, can I make it negative? Or 0. Although if you look at the statement, you'll pretty quickly see that V can't be 0. Because if it were 0, then this would be impossible. But still, that theoretically that would be how you make a no case. So here's statement 1, here's statement 2. If we can check off both boxes in a column, then that's not sufficient. And again, this device is a really good thing to do in your life when you have a yes/no data sufficiency question in front of your face. Because it does 2 things. I mean, the first thing that it does is it cements the importance of these goals, right? If you make this on your paper and you are staring at it with your eyes, then you can't forget that you're supposed to figure out whether you can do these 2 things. But the other importance of this is just the fact that it is a thing. And that sounds stupid, but it's a thing, meaning it's a step 1. It's a first step of the process. Because a lot of people say stuff like, I don't really know where to begin the process. And that's fair. The first step is the hardest step of a lot of things, but when you do this device, it's always a first step that you can do. It is a thing that you can make. It gets rid of this problem of writer's block, I don't know what to do first, and on top of that, it helps to direct your thoughts towards the goal. So you should really, advocating very strongly for making this device. You should do it, and it's free. Okay, so, well, what can we do with this thing? Remember that you should be thinking about signs. So let's merge those 2. Aha, right? Because then if you look at these with your eyes over here too, I mean, this is going to come about like, okay, I see they're trying to divide by V. At least in this statement, that's pretty clearly what they're trying to do. And then here they're also looking like they're trying to divide by v in some sort of sense, because we have mv here and we have not v here. So pretty clearly directed, right? A lot of upfront work that we can do before we go to the statement. So let's see what happens if we do that. So if we try to divide by v, there's going to be two cases here. I mean, v can't be 0 because then you can't have mv and pv be the same number. That would make mv and pv the same because they both be 0. So we still have to consider the two cases of if v is positive. And I'm going to be super lazy and just copy and paste this. V is 0, positive, if it's greater than 0 rather, then we can divide all three sides of this inequality by it. Sure. And then what we can do that, we don't need to worry about switching inequality signs because it is positive. So that would give us m less than p less than 0. That's a thing. On the other hand, we also need to think about what happens if v is negative. So what's the difference? Maria knows what the difference is. The difference is this. Gotta flip these guys. When you divide inequalities by a negative number, flip it around. So that's going to give us m is actually more than p, which is actually more than 0. Indeed. And then we're not really used to seeing inequalities written in that direction, so you can also write it as this. And there you have it. Now you have an exhaustive list of possibilities. This is one of them, and this is the other one. Neat. Also notice that this works both ways. Like if these are mutually exclusive cases. So not only does it go in this direction, but it also goes in the other direction. And same thing, this goes in this direction, but it also goes in the other direction. Because these are mutually exclusive. If you know this, then you also know that. And if you know this, then you also know that. So statement 1 is only happening in this case. Statement 1 is not possible in this case. So check first box. Cannot check second box. That's sufficient. Yes, indeed it is. And then m is negative. Well, that happens here. Cannot happen here. So we're dealing again with b strictly positive. So there it is. It's also sufficient. This is d like dog. Okay. Another thing that's interesting about this problem is that you can also, rather than hashing all of this out at the beginning, the other thing that you can do is isolate the pieces of that three-part inequality that you need at any given point. Right, because like in statement 1, so here is your inequality. Like if you're going to do statement 1, I mean, basically you're just not using this part of it. And so then if you look at this and you look at this, it might jump right out at you that v has to be positive. Like, you know, the 0 in there looks like, makes it look like it's more complicated than that. But oh, hey, the sign is preserved. So this means that v has to be positive. And then similarly, here's that three-way inequality again. I mean, this time, this time we don't need the meat of the sandwich. We can just use the slices, right? I mean, we can just use the m being into 0. This and this. So then, if m is, this is like a sign exercise, right? So m is negative and mb is negative. If you think about that for a second, if you just use your sign rules, that's going to tell you that b is positive. You can also do it that way. So there's also a takeaway here about if you have inequalities that have more than 2 parts, then you might want to think about whether you even need to work with all those parts at once. And maybe you don't. Any questions about this problem? My notes. All right. No questions. Let's take a look at another one. How about is D dog, as we said on the other slide. D like a dog. All right. How about that? Give it a go for it. Okay, ladies and gentlemen, let's pick a thing. We are also floating all over the place on this. Although, at least one of these statements you should be able to rule out if you think about it for a sec. Because people are basically guessing on this problem, let me take the problem to the next page and black out some of it, and then we can discuss. Here, even if you don't see these words, let's talk about that for a second, guys. Someone tell me a story about that. That's actually all you need to figure out statement 2. Why? It's because there's no information about why, and moreover, because it's about quadrants. Because it's not, you still have to actually think about this. Because you can have, it is possible, just warning here. Oh, hey, I don't see whatever variable. Does not guarantee insufficiency. No, it does not. It's actually pretty easy to make up. You don't need any really weirdly contrived examples to be counterexamples. Like, let me just make a pretty pedestrian example up here. Like, for example, if you have if x and y are positive integers, is x, y odd? Okay, if I tell you that x is even, well, this is sufficient. Right, so you still have to think about the problem. You still need to think about what is required here. Because if I tell you this, then that's actually enough to know that x, y is even. So when you say no info on why, that's half the puzzle, but you still have to actually think about the nature of the question. Because if you had a different type of question, like this right here, then you might still be sufficient even without mentioning a letter. So, but yeah, see quadrants, right? The deal is that if you don't have y, any information about y, we know that we can switch quadrants by switching the sign of y. Right? So, it could be, now that I think about it, no, it's still not good enough to guarantee it. Because it has to be the same quadrant as something else. So no, actually this is not good enough to guarantee insufficiency. I eat my words. Because if the quadrant was one of the other two, then you might still get a definite no. So no, we don't know, right? So it doesn't. It's not enough information. I guess I was just kidding, haha. Still could be sufficient, like if whatever the same quadrant is one of the other two, or insufficient. So yeah, no, we can't do that. But it's still worth thinking it through, right? It's still worth thinking through that whole situation. So now let's look at all the words. This is all words. What do you do with this? I mean, this looks weird and scary. And this is one of those exceptions. With coordinate geometry problems, you usually try to visualize the situation. They usually give you problems that are visualization friendly, but this one is absolutely not visually friendly. So, what does that mean? What do you do with that? So at least when you look at this statement, yeah, it has to do with sign, right? I mean, when you look at this statement, at the very least, you should see this statement and be like, I know I have to do something with this up front. I mean, you might not know what that is, but it should be absolutely clear that you have to do, well, something up front with this. It may not be clear what that is, but think about the signs. So what does it mean to be in the same quadrant? Like what does that mean about? You could pick numbers, although that might get confusing because of the negative signs that are on the A's and the B's. But you could try that. You could. If you just make up random values, then. Because like it should be clear that if A and B are the same number, then these will definitely be in the same quadrant because they are the same points. But yeah, quadrants are defined by the signs of the coordinates, right? So like if you have, like let's say you had 4 letters instead of 2. Like if you had the point A, B, and the point C, D in the same quadrant, then what that would mean is that A and C have to be the same sign, and separately B and D have to be the same sign. Because the quadrant means that you have the same sign on both of the coordinates. Not the same sign as each other, but the x-coordinates have to be the same and the y-coordinates have to be the same. So this would mean that A is equal to C. And it would also mean that boy is equal to dog. Okay. So, but here, if we use the same kind of color coding, we know that B and I don't mean equal when I write equal. I mean sine of A equals sine of C. No, they could be different values, right? Sorry if that was unclear. That's what I mean by that. So in this statement, that second group tells us that sine of B has to be the same as sine of A. And actually, if you turn your attention to the x-coordinates, you wind up getting redundant information. This actually doesn't tell us anything that the second coordinates don't tell us. Sine of minus A equals sine of minus B. These are actually the same statement twice. So we know that the sine of B is the same as the sine of A. So we can cross off this horrible phrasing of that and just say, we know that the sine, that A and B have the same sign. And the same non-zero sign. Okay. So then, is the point negative x comma y in the same quadrant? That means negative x, it's got to be blue also, and y is got to also be pink. So let's get rid of that over there. So the bulk of this problem, the bulk of the difficulty that you have with this problem is probably going to be just getting a handle on what the yes and the no cases mean. So a yes to the question means that both of those colors correspond. It has to mean that minus x has the same sign as minus A and minus B, which means the same thing as X has the same sign as A and B. And separately about Y, that's the pink fact, Y has the same sign as A and B. I don't have random ratio problems on me. No, because that's not the theme of today. I don't think any of the ones in today's slides are ratios. In fact, I'm pretty sure they're not. But I think there's a couple of study halls that are specifically about things like ratios and such things. So, okay. X is the same sign as A and B, and also Y is the same sign as A and B. This whole behemoth here is the yes case. So we can make our gigantic device here. Statement 1, statement 2, and then if necessary, we combine the statements. Okay. And then the no case would just be either of these is not true. One or both of those is false. So if you could make either X or Y have the not same sign as A and B, then you can check off the bottom box. So this right here, I mean, obviously everybody here has a better memory than I do, but there's no way that I could possibly remember that these were goals without writing them down. So, but if you do write this down, you realize it's not so bad. I mean, these are actually pretty straightforward goals. It's really just remembering that they are the goals is where the trouble is at. So, statement 1, we have statement 1. What do we know from statement 1? Yeah, it means that X and Y have the same sign as each other. But the problem is that doesn't tell you anything about the question. Because it's not, we don't just want to know whether their signs are the same as each other. We also want to know whether they are the same as A and B. So there are basically two possibilities. You should still think specifically about what they are. The first is that they have the same sign as A and B. If that is true, then we can check off the box. The other possibility, though, is that they're both the opposite sign. So that would check off the bottom box. This would be not sufficient. Statement 2, so still can't take anything for granted. What does statement 2 tell you? tells you that A and X have the same sign. So that means but Y could go either way. So, and this is where you figure out how this is going to work out. Like if X has the same sign as A, then you got half of what you need here. But if Y is also the same, then you can check off this box on top. But if Y has the other sign, then you don't have both conditions. And so we check off the bottom box. This is also not sufficient. And so we combine them. If we put these together, then you can see that we're going to have what we need for top condition. Because if we put these two together, then we know that X and Y do have matching signs. And then from the other statement, we know that those signs are going to match what A and B are. So, or if you treat it in the reverse order, we know that X matches A and B. And then this tells us that Y will also match A and B. So if you have the two statements together, this is now impossible. And that is sufficient. And this is C like cat. There it is. Any questions? Does anybody see what happens here? Let me throw a little curveball right here. So I make these left-hand signs. Let me clear out your answers. I'm going to leave everything else on the board. But see if you guys can see what happens with that. You go ahead and answer it in the multiple choice area. You probably wouldn't finish it. So you got another problem on the board now. The same problem, but not the same problem. So now answer this. Everybody who's answered it so far is wrong, by the way. Someone just changed the right answer. One person did. All right, ladies and gentlemen, let's talk about it. We have a very interesting pattern of answers here. We have like equal popularity of these three things. And then we have the most popular answer is not an answer, it's a non-response. Should pick something. I mean, it shouldn't take this long, right? Because it's the same problem as we had before. So all of this junk is at least figured out. We didn't change the nature of the question. So this, at least, you're not working it from scratch, so you should have an answer by now. That means you should pick one if you don't already have one. Okay. So remember, you need to not modify anything whatever you have written. Well, I don't know what you mean by that. What do you mean by that? Yeah, no, the device is still the same there, right? Because I mean, the checkoffs are not the same. I mean, this problem works out very differently. I mean, it's not going to work out the same way. Otherwise, I wouldn't have bothered, right? But notice, okay, the yes case here means that you have to have both x and y having the same sign as both a and b. That's the only way to get the top box checked off here. So statement 1, guys. What does it mean if you multiply two numbers together and get a negative? It means we got not the same sign as each other. Yeah. Whoa there. So statement 1 means that x and y have opposite signs. I mean, to check off the top box, everybody has to have the same sign. Like A, B, X, and Y all have to have the same sign. So if this is true, then you are not getting this box. No, sir, no, ma'am. The only thing, I mean, at least one of, in fact, exactly one of those is going to be false. So this is going to be sufficient because only one of these things is true. Yep. And then with statement 2, I mean, remember the only way to get this happy top line here is if all of x and y and a and b have the same sign. So statement 2 says that you are guaranteed that that is false, at least for x, because x has the other sign. In other words, not the sign of a. So this is impossible to check this box again. So this is going to force the bottom box. This one is also sufficient. Like this one is D, like dollars. How about that? Totally different problem if you just flip the signs around. And again, this is the kind of messing around with statements that you should do when you review problems. I mean, the one thing that is sort of fraught about that is that you don't have an answer key, but you can at least still brainstorm what would happen if you mess with stuff. Because another thing that you will discover when you do this is that usually the outcome of the problem does change if you play with stuff. And what that means is that like there's a very intricate dance of these statements with each other and how everything interacts. Because I mean, if these problems were as easy as a lot of people mistakenly think they are, then really changing stuff wouldn't really matter much. But they're not. They're very. I mean, everything here is chosen very deliberately for a reason. So, and if you flip stuff around, it usually alters the outcome of the problem. And if you really change anything, it has a way of changing the outcome. So try playing with that when you review the problems, and you'll discover a whole world of cool stuff. And again, when you do that, you're gaining the most valuable insight, which is this whole think like the test maker thing. Because again, that's just the value of that just cannot be overstated. Because I mean, when you look at something like this problem that's right here, I mean, once you do that a couple of times, you will look at things like this and you will totally know what the deal is right away. Like you'll look at this and be like, boom, dude, I need to think about n being 0. And then, or maybe a non-integer. And then you'll see this and you'll be like, okay, obviously I have to think about zeros and negatives. So, and that insight may not be as obvious if all you do is just solve problems and solve the problems some more without thinking about them from the test maker end. So think about it from both sides. Thing. And that is it. All right, let's kill it. Statement 1 doesn't make that happen in our altered version. In fact, it means that one of them will not do that. So, yeah. If you have statement 1, then exactly one of x and y will do that, and the other one won't, which is why this is impossible to check off. Okay. Tight schedule, got to run here. Going to kill the recording. Good afternoon, good evening, good night, good luck.